All right, so if you've ever actually tried to code with an AI agent, you know this feeling. It's a special kind of frustration, right? You're deep in a session, everything's flowing, and then poof, the AI just forgets. It forgets the files you were working on, the tasks you gave it, even the big decisions you made just a few minutes ago. This is called context bloat. And it is easily one of the biggest headaches for developers using AI today. And believe me, the clock starts ticking the second you start your session.
Yeah, this quote from the source material, it just hits hard. 30 minutes. That's it. That's pretty much the average productive lifespan of a coding session before your AI partner starts to get amnesia. It's a huge bottleneck, and it costs you in both time and, well, a lot of tokens.
And look, this isn't a slow burn. It happens fast. You run one single totally normal command, like taking a playwright snapshot of a web page, and boom, you've just dumped 56 kilobytes of raw data straight into the AI's very limited memory. And it just keeps piling up. Let's say you need to read, I don't know, 20 GitHub issues to get the lay of the land. Well, there goes another 59 kilobytes. You can see how just a few of these basic steps can completely eat up your context window before you've even written a line of code. And this is where you get what's basically session amnesia. To save space, the agent has to compact its memory. But in doing that, it throws out vital information. Next thing you know, you're back at square one, re-explaining everything, and completely derailing your workflow. So the big question is, how do we fix this thing? Well, in this explainer, we're going to break down a really brilliant solution. We'll start by digging a little deeper into the context bloat problem, then we'll look at a virtualization layer that solves it, see how it keeps the session going, check out the incredible results, and finally, discover why this is about way more than just saving a few tokens. Okay, so the hero of our story here is a tool called Context Mode. It's what's known as a machine control program, or an MCP server. It's specifically designed to be the smart middleman between the AI and your computer, and it tackles that memory problem head on. The easiest way to think about it is like this. Right now, the AI talks directly to your computer, and it just gets flooded with all this raw data. With context mode, it talks to this sandbox environment instead. The sandbox processes all that information first and then only passes back the tiny, essential pieces the AI actually needs. So how does it actually pull this off? Well, it's not just one single magic trick. It's actually a really clever combination of techniques that work together to give the AI a persistent, super efficient memory. When you dig into the documentation, it all comes down to these three core pillars. First, there's aggressive context saving through sandboxing. Second, you have session continuity, which is handled by a knowledge base. And third, there's a really important shift in strategy called the think-in-code paradigm. First up, the sandbox. This is your first line of defense. When the AI wants to run a command, like reading a massive log file, it happens inside this isolated environment. All that raw data, we're talking kilobytes, maybe megabytes of text, it never even touches the AI's context. The only thing that gets sent back is the final, concise result. That's it. Okay, so that handles the raw data. But what about everything else? You know, the file edits, the git commits, the error messages. That's pillar number 2. Context mode takes all of those events and indexes them into a local SQLite database. This becomes the AI's long-term memory, a searchable knowledge base it can check anytime to remember what happened in the session. Now, the real magic, the glue that holds all this together, is a system of session hooks. Think of them as automated triggers that are constantly watching what the AI is doing. Right before the context window needs to be compacted, a hook jumps in, saves a snapshot of the current state to that knowledge base, and then injects a tiny summary back to the AI. It's exactly like hitting a save checkpoint in a video game. Let's walk through a super simple example from the demo to see how this plays out. You ask the agent to find errors in a giant log file. Instead of trying to read the whole thing, context mode just indexes it into its database. All the agent gets back is a tiny little confirmation message that says, okay, file indexed. From then on, the agent can run smart queries on that database to find exactly what it needs, all without ever seeing the context-destroying raw data. All right, so the theory sounds amazing, right? But does it actually work in practice? Well, the numbers, they're honestly pretty staggering. So let's take a totally standard task, right? Researching a code repository. Without context mode, the AI burned through almost a full megabyte of context. With context mode turned on, that number just plummeted to 62 kilobytes. That is a massive difference.
And this chart just makes it so obvious. I mean, look at that. On the left, you had this mountain of context being used by just the raw outputs of the tools. And on the right, that tiny little sliver is all that's needed when context mode is managing the session. It is a night and day comparison.
So, when you average it all out, what do you get? You get this, 98%. A 98% reduction in context window consumption. Just let that sink in for a second. This isn't some small optimization. This is a fundamental game changer.
So what does the 98% savings actually mean for you, the person coding? Well, remember that 30-minute session limit we talked about at the start? With this, you can extend that to roughly 3 hours. That is a huge leap in productivity. It lets you tackle much more complex problems without interruption.
But here's the thing. This is about so much more than just saving tokens. The real payoff is how it fundamentally changes the way the AI operates, pushing it to work in a much more intelligent way. This quote right here just nails the whole philosophy. The goal is to shift the AI's job away from being a slow, expensive data processor and toward being an efficient code generator. So instead of making it read 50 different files just to count how many functions are in them, you have it write a tiny script that does the counting and just gives you the final number. It stops being a clerk and starts being an engineer. You see, by filtering out all that raw data, all that noise, you're doing more than just saving space. You are freeing up the AI's cognitive capacity. You're giving it the mental room it needs to actually reason, to plan, and to be a much more effective partner in your coding. And that really is the big takeaway here. Tools like context mode are solving the AI's memory problem, and they're doing it right now. So the real question for all of us becomes, what new, complex, and ambitious projects are now possible when your AI partner has a perfect, persistent memory? What could you build if it never forgot?